Okay, so hi guys. So again, this is ACI 1 Analog Aircraft Instruments, Module 4. We will talk about the altimeter. So as you can see here, pag sinabing altimeter is an instrument that is used to indicate the height of the aircraft above a predetermined level such as sea level or terrain beneath the aircraft. So the most common way to measure the distance is rooted in discoveries made by the scientists centuries ago. So, mga panahong 17th century, work proving that the air in the atmosphere exerted pressure on the things around us led Evangelista Torricelli to the invention of the barometer. Also in that century, using the concept of this first atmospheric air pressure measurement instrument, si Blaise Pascal was able to show that the relationship exists between the altitude and the air pressure. So, pinapakita lang dito, tapos natin dito. Yan. As altitude increases, pressure decreases. So, the amount that it decreases is measurable and consistent for any given altitude change. Therefore, by measuring air pressure, altitude can be determined. So, kung makikita nyo dito, sa figure, okay, yung altitude measured in feet, and yung pressure measured in PSI. So, at sea level, sinasabi sea level, so yung altitude niyan is 0. So, sa 0, it's 14.69. Actually, 14.7 lang. Yan. So, round off na lang. Okay, 14.7 para mas mabilis matandaan. So, pag tumaas ka ng 2,000 feet, mabot ng 13. And then, pag 4,000 feet, 12. Then, pag umabot ka ng 15, yung pressure mo doon is 1.68. So, the altimeters that measure the aircraft altitude by measuring the pressure of the atmospheric air are also known as pressure altimeters. Ulitin natin, ha. Yan. Tinatawag siyang pressure altimeter. So, si pressure altimeter is made to measure the ambient air pressure at any given location and altitude. So, pag sa aircraft, connected siya sa mga static vents. So, nakita niyo kung ano itsura ng static vents via tubing in the pitot-static system. So, the relationship between the measured pressure and the altitude is indicated on the instrument face or yung mismo dun sa may dial, which is calibrated in feet. Okay? So, isa lang indication, puro feet. 10,000 feet, 14,000 feet, 28,000 feet. So, itong mga device na to are direct reading instrument that measure absolute pressure. So, meron siyang aneroid or aneroid bellows sa may core ng pressure altimeter's inner workings. Yan, kung makikita nyo, meron siyang aneroids and aneroid bellows. Attached to is the sealed diaphragm. Yan. Are the linkages and gears that connected to the indicating pointers. So, ito yung mga linkages. Yan. And gears papunta dun sa may pointers. So, yung static air pressure enters the airtight instrument case. Okay? Meron pa din pumapasok na hangin dyan. Static air pressure sa instrument case. And surrounds the aneroid. Dyan, surrounds the aneroid. So at sea level, the altimeter indicates 0. So when this pressure is exerted by the ambient air on the aneroid, yung air pressure is reduced by moving the altimeter higher in the atmosphere. So the aneroid expands and displays altitude on the instrument by rotating the pointer. So the altimeter is lowered in the atmosphere. So the air pressure around the aneroid increases. Yan. And the pointer moves in different direction. So kung titignan nyo dyan sa figure 10+31, yung internal arrangement of the sealed diaphragm pressure altimeter. So ulitin natin, at standard atmospheric condition, the linkage attached to the expandable diaphragm, ito yung expandable diaphragm yan, produces an indication of 0. So when an altitude increase, static pressure on the outside of the diaphragm decreases and the aneroid expands, producing a positive indication of altimeter. So when the altitude decreases, atmospheric pressure increases, so the static pressure on the outside of the diaphragm increases and the pointers move in the opposite direction. Nag-i-indicate siya na nag-decrease si altitude. So, pinapakita lang dito na the relationship between the measured pressure and the altitude is indicated sa may instrument face. It's calibrated in feet, and ulitin lang natin na ito ay direct reading instrument that measure absolute pressure. So kung nakikita nyo naman ngayon, okay, the phase of the dial of the analog altimeter, yan. So ito yung harapan ng altimeter. So the phase or the dial of the analog altimeter is read similarly to a clock. So as the longest pointer moves around the dial, the longest pointer. So hanapin nyo yung longest pointer. Kung nakita nyo na yung longest pointer, inyong hundreds of feet. Okay? Ito yan. Longest pointer. So nag-i-indicate siya ng hundreds of feet. So pag naka-isang ikot na yung hundreds of feet, isang revolution, nag-i-indicate siya ng 1,000 feet of altitude. So, si second longest pointer moves more slowly. Each time it reaches a numeral, it indicates 1,000 feet altitude. Yan. So, once na umikot ulit, si pointer equal to 10,000 feet. So, the longest pointer travel around the dial one time. So, the second longest point moves only the distance between two numerals, indicating 1,000 feet of the altitude is nothing. So, meron pa tayong pangatlo. Meron tayong shortest and thinnest. Yung pinakamanipis. Nagre-register yan ng 10,000 foot increments. So, ito. So, sabihin na-attain mo na yung 10,000 feet. So, sometimes a black and white or red and white crosshatch area is shown on the face of the instrument until the 10,000 foot level has been reached. Okay? Itong nakikita nyo to. Pwede yang black and white or red and white. Ibig sabihin, naka-reach na siya ng 10,000 feet or foot sa taas. So, lahat ng altimeters nagko-contain ng linkages that rotates a numerical counter in addition to moving pointers around the dial. So, merong quick reference windows allow the pilots to simply read the numerical altitude in feet. So, the motion of the rotating digits or the drum type counter during the rapid climb or descents make it difficult or impossible to read the numbers. So, kung titignan nyo dito, ayan, merong drum type counter. Bakit siya drum type? Ito yung sinasabi natin. Mas mabilis mo siyang makikita kung anong feet na siya. So, ulitin lang natin, the motion of the rotating digits sa mga drum type or rapid climb or descents, siyempre, minsan mahirap basahin. Kaya merong yung clock style na sinasabi. So, kung nakikita niyo sa figure na to, illustrates the inner workings behind this type of mechanical digital uh, display of pressure altitude. So, meron naman din, kung nakikita niyo sa figure na to, true digital instrument display can show in numerous ways. So, meron tayong ginagamit na numerical display rather than a reproduction of a clock type style. So, itong digital numeric display of altitude is given sa mga electronic primary flight display malapit sa may artificial horizon. So, ito yung artificial horizon. Siyempre, ito si altimeter. Mas mabilis mabasa. So, a linear scale may also be represented to put this hard numerical value in perspective. So, kaya, linear. Ito na yung naka-linear na siya. And, tumataas or bumababa lang yan para mas mabilis yung mabasa si altimeter. So, example to ng Garmin 1000 series sa isang glass cockpit instrumentation para sa mga light aircraft indicates altitude using a vertical linear scale and numerical counter. So, nagkakaroon tayo ng accurate measurements of altitude for numerous reasons. So, yung importance is magnified in the instrument flight rules conditions. So, for example, avoidance of tall obstacles and rising terrain relies on precise altitude indication as does flying at prescribed altitude assigned by the ATC to avoid colliding with other aircraft. And measuring altitude with a pressure measuring device is fraught with complications. Kaya kailangan maayos yung pagbasa ng altitude indication to compensate for the factors that may cause inaccurate display. Major factor that affects pressure altitude measurements is naturally occurring pressure variation through the atmosphere due to weather conditions. dahil meron tayong different air masses develop and move over the Earth. Okay? So, I guess naintindihan niyo naman yun na kada lipat mo, okay, sa iba't ibang lugar, nag-iiba yung air masses dahil due to weather or nagkakaroon ng iba't ibang pressure value. So these air masses cause the weather we experience, especially at the boundary areas between air masses known as fronts. So sa mga sea level, even if the temperature remains constant, yung pressure pwedeng tumaas or bumaba due to the weather system na madadaanan ng isang aircraft. So to maintain the altimeter accuracy, despite the atmospheric pressure, a means for the setting was devised. An adjustable scale visible on the face of an analog known as barometric or Colesman's window, which is nakikita nyo yan dito. Yan, barometric adjustment knob and si Colesman window. Nilalagay yung altimeter setting dyan. So this adjustment is linked through the gear inside the altimeter to move the altimeter altitude indicating pointer on the dial as well. So by putting the current known as air pressure in the window, the instrument indicates the actual altitude. So this adjusted for atmospheric pressure changes due to weather and air masses pressure inconsistency is known the indicated altitude. Okay, so example lang, ikaw ay lumilipad from point A to point B. So sa altimeter settings mo, lagi namang madalas is 29.92 inches of mercury. And pupunta ka sa point B and sinabi sa'yo ng tower up, ito yung iyong altimeter setting. So, papalitan mo to due to air masses na meron doon sa point B. So, para tama yung height mo and yung vertical distance mo sa iba't ibang aircraft. So, ganun ginagamit si altimeter. So, kaya it must be noted that in the flight, the altimeter setting is changed to match the closest available weather reporting station or sa may airport mismo para yung progress mo ay accurate during the flight. So, while there was little need for exact altitude measurement in early fixed-wing aviation, knowing one's altitude provided the pilot with useful reference while navigating in the three dimensions of the atmosphere. So, as the traffic grew and the desire to fly in any weather condition increased, exact altitude measurements become more important and the altimeter was refined in 1982. So ulitin natin, si Paul Boltzmann invented the means for adjusting an altimeter to reflect the variation in air pressure from the standard atmospheric pressure. And then the next year, si Jimmy Doolittle made his successful flight demonstrating the feasibility of instrument flight with no visual reference outside of the cockpit using the Boltzmann sensitive altimeter. So, yung term ng pressure altitude ay used to describe the indication an altimeter gives when 29.92 is set in Boltzmann window and when lying in the US airspace above 18,000 feet, mean sea level, pilots are required to set their altimeter nga dito. Even ikaw ay makaramdam ng low pressure or high pressure. So, ibig sabihin, yung magiging distance ng aircraft mo dito between 1 and 2 ay nagiging accurate. And then, balikan pala natin, no? para pala magkaroon tayo ng idea. Ayan, para magkaroon kayo ng idea dito, basahin nyo, tignan nyo kung anong lumalabas sa altimeter niya. So, ulitin natin, ito ay 100 foot increment. And ito ay 1,000 foot increment. Ito ay 10,000. So, hindi pa siya lumalabas sa 10,000. Dahil pag lumagpas na siya sa 10,000, indication nung thickness niya nandito. So, kung mapapansin nyo, between 6 and 7, ang kanyang 1,000 foot increment. So, 6. Next, 100 foot increment nakatapat sa 5. Daling basahin. So, 6,500 feet. Next, kung titignan nyo to, dito, basahin din natin. Ito si 1,000 feet, 10,000 feet, and 500. Okay, so kung babasahin nyo, tagpas siya ng 10,000 feet. So, 10,500 feet siya banda. Ito hindi nyo ito mababasa, pero kung idadamay nyo, pwede naman siya. 10,520 feet in aircraft altimeters na to. Next, kung titignan nyo naman dito, yan. Ito ay 1,800 feet lang. Yung altimeter ng aircraft na to. So, hopefully, nakukuha nyo yung pagbasa sa altimeter. So, ulitin lang natin. Okay, the term pressure altitude is used to describe the indication an altimeter gives when 29.92 is set sa may Qualsman's window. So, pag pumasok ka sa US territory, dapat naka 29.92 yung altimeter setting mo, and pag nasa above 18,000 feet ka. So note that the true altitude or actual height of an aircraft above sea level is only the same as the pressure altitude when standard day condition exists. So kahit gabi yan or umaga, same lang din. So this is due to the pressure within the air mass in which they are flying being above or below standard day pressure, 29.92. The actual or true altitude is less important than keeping the aircraft from colliding, which is accomplished by all aircraft above 18,000 feet, referencing the pressure level 29.92 inches of mercury. And then the temperature also affects the accuracy of an altimeter. So the aneroid diaphragm used in altimeter usually made of metal. Okay, gawa siya sa metal. So the elasticity changes as the temperature changes. So this can lead to a false indication, especially at high altitude when the ambient is very cold. So a bimetallic compensating device is built into a many sensitive altimeters to correct or varying temperature. So babalikan lang natin, patulad siya dito. So kung titignan nyo, meron siyang bimetal compensator. Nandito na din pala. Yan. So si bimetallic is for compensating for the temperature. Okay, the temperature also affects the air density, which has greater impact on the performance of an aircraft. So the term altitude describes correct for non-standard temperature. That is, the density altitude is the standard day altitude at which an aircraft would experience similar performance it would on the non-standard day currently being experienced. So the conversion factor and the charts have been produced so the pilot can actually calculate the density altitude on the particular day. Inclusion of the non-standard air pressure due to weather systems and humidity can also be factored. So while the effects of the temperature on aircraft performance do not cause altimeter to indicate falsely, an altimeter indication can be misleading in terms of aircraft performance if these effects are not considered. Kaya kung titignan nyo dito sa may figure na to, okay, so yan, at sea level, punta yan sa 15 degrees. And pag tumataas yung altitude ng aircraft, ano nangyayari? Mababa din yung temperature. So, other factors can cause an inaccurate altimeter indication. Yung scale error is a mechanical error whereby the scale of the instrument is not aligned, so the altimeter pointer indicate correctly. So, kailangan siyang i-test and adjust ng mga technicians using a calibrated equipment para yung scale error is kept at minimum. So, the pressure altimeter is connected sa may pitot-static system and kailangan makareceive ng accurate sample for ambient air pressure to indicate the correct altitude. So, position error or installation in is caused by the location of the static vent that supplies the altimeter. Okay? So, yung pagkakalagay din ng static pressure. Okay? So, the amount of the air pressure is collection is measured in test flights and correction table showing the variance can be included with the altimeter for pilot use. Kaya sa mga modern aircraft, okay, sa mga modern aircraft, Normally, the location of the static vent is adjusted during the test flights para din yung mga position error is maging minimal. So, position error can be removed by ADC in modern aircraft, so the pilot need not to be concerned about this inaccuracy. Static click can affect the static air input to the altimeter or ADC, resulting in inaccurate altimeter indication. So, kailangan siya ng 24 months ng leak checks regardless of whether any discrepancy has noticed. So, kailangan pa rin i-maintain yung ganitong instrument. It's a mandatory check para din for proper care upon the installation and magkaroon ng preventive action. So it should be noted that many modern altimeters are constructed to integrate into flight control systems, autopilots, and altitude monitoring system, such as those na ginagamit ng mga ATC. So the basic pressure sensing operation of the altimeter is the same, but a means for transmitting the information is added. That's all for Module 4.